topics, which is define overfitting, underfitting in the context of machine learning models, describe how these issues can be identified and list strategies to prevent or mitigate them. So, have you ever trained a machine learning model that works like magic on your training data, but perform terribly in the real world? Well, that's overfitting. And if a model does not learn anything at all, that's underfitting. So in this video, we will understand both clearly, visually, and with some simple examples. So let's start. So what make a good model? So in machine learning, a model is considered good if it can do two things: learn patterns effectively from training data, and second, generalize well to new unseen data. And most importantly, it should avoid memorizing the data, overfitting, and avoiding missing important patterns. It is underfitting. So let's start. So underfitting and overfitting we have already done. Machine learning models aim to perform well on both training data and new unseen data is considered good. If it learns pattern effectively and training data, it analyzes well to new and unseen data. It avoids using data overfitting. That's well done. Moving to the bias and variance in machine learning. Bias and variance are two key sources of each of error in machine learning models that directly impact their performance generalization ability. Bias is the error that happens when a machine learning model is too simple and doesn't learn anything enough with enough details from the data. It's like assuming all birds can only be small and fly. So the model fails to recognize birds like ostrich or penguin that can't fly and get biased predictions. So in bias, so let's understand bias some more. Bias happens when a model is too simple and it's make strong assumption and misses important patterns. And like for example, assuming all birds can fly by ignoring penguin and ostriches. Okay. So this assumption make the model easier to train but may prevent it from capturing the underlying complexity of the data. So high bias typically leads to underfitting, where the model performs poorly on the both training and testing data because it fails to learn enough from the data. So the core concept is that the high bias leads to underfitting, and when the bias happens, it's happen on the small and simple data which the model is performing on. For example, a linear regression model applied on to a data set with nonlinear relationships is an example of bias. Moving on to variance, error that happens when a machine learning model learns too much from the data being randomized. So a high variance model learns not only the patterns but also the noise in the training data, which leads to poor generalization or unseen data. So high variance typically leads to overfittings, where the model performs well on training data but poorly on the testing data. So high variance leads to overfitting. And variance happens when the model learns too much. Even noise is also learned by the model, so it becomes hindrance in the working of the model, and it becomes overly sensitive to the training data. Okay, so now the core issues of overfitting in machine learning are: overfitting happens when the model learns everything, including noise and outliers. Example, for example, imagine. One sec. For example, imagine fitting a very complicated curve to a set of points. The curve will go through every point, but it won't represent actual pattern. As a result, the model works great on the training data but fails when tested on a new data. Overfitting models are like students who memorize answers instead of understanding the topic. They do well in practice tests but struggles in real exam. That's like me. So the reason for overfitting: high variance and low bias. The model is too complex and the size of the training data is more. So the simple analogy is the student memorize answers instead of understanding concepts. The great practice stats but very really bad in exams. So this is an graph of high variance overfitting where we can see the graph is passing through the all points, but it does not make any sense at all. Underfitting in machine learning happen when the model is too simple to learn the actual pattern. For example, imagine drawing a straight line to a fit points. It actually follows a curve. The line misses most of the patterns. Uh, it is that when we draw a curve, we are missing some points which may not be are useful, but they are getting missed. That is underfitting. The reason for underfitting is model is too simple, or the feature is not sufficient, and not enough training of the data has been done, and too much regularization, and the feature is not scaled. So in this case, model does not work well on either the training or the testing data. And we should note that the underfitting model has high bias and low variance. The reason of underfitting is the model is too simple. We have already done. The input feature is also used to train the model is not adequate to generating and the underlying factors influences the target variable. So the size of the training data set used to be not enough, and the excessive regularization are used to prevent the overfitting, which constrain the model to capture the data well, and the feature are not scaled. These are some reasons for the underfitting. So this is example of a high bias data set where we can see a straight line passing through some points but missing every each and every one point of the graph. And let's visually understand the concept of underfitting, proper fitting, and overfitting. So here we can see high bias, which is underfitting, missing every point, and then we can see the low bias, low variance, which is good fitting, where some points have been covered, and in high variance there is a graph which is completing the all points, but it does not make any sense. So underfitting is a straight line trying to fit a curve data set but cannot capture the data patterns, leading to poor performance on both training and test sets. Overfitting a squeezely curve passing through all training points, failing to generalize, performing well on the training data but poorly on the test data. An appropriate fitting curve that follows the data trend without complicated to capture the true pattern in the data. So how to address overfitting and underfitting? Techniques to reduce underfitting is to increase the model complexity and increase by increasing model complexity the major issue was that it was very simple, so we should make it complex. And by increasing the number of features, performing features and engineering, we can remove noise from the data and increase the numbers of epochs or increase the duration of training to get better results. And some techniques to reduce overfitting are improving the quality of the training data, reduced overfitting by focusing on meaningful patterns, mitigating the risk of fitting the noise or irrelevant features. We can also increase the training data. We can also increase the training data can improve the model's ability to generalize to unseen data and reduce the likelihood of overfitting. And we can also reduce model complexity. So in underfitting we have to increase the complexity, and in overfitting we should decrease the complexity of the model. And reduce overfitting we can also do early stopping during the training phase. We can have a look first what is lost and what is the it is the model is doing, so we can change it. And also the ridge regulation and lasso regulation are some formulas or some experiments we can do on the reduced fit fitting. And also we can use dropout for neural networks to tackle overfitting. So that's it guys. Yeah, so that's it guys. Cut kar dena. So cut kar dena. So that's it. So that's it guys, we have done the question number 6 also. We have given the correct answers of the questions. We have defined overfitting and underfitting in the concept of machine learning, and also we have described the issues and identified lists of strategies that from which we can prevent the overfitting and underfitting, and also mitigate them, and so we can completely vanish it. So thank you so much for watching my video, And next video we